Imagine a detective, but instead of chasing criminals, they chase diseases. This is the world of epidemiology. It is the study of how diseases spread, who gets sick, and why. Epidemiology is the science behind understanding disease patterns in populations. It helps us answer critical questions. Where do outbreaks occur? What are the risk factors? How can we prevent future epidemics? By studying large groups of people, epidemiologists identify trends and risk factors that might go unnoticed at the individual level. This information is crucial for developing public health strategies and interventions. Epidemiology is the foundation of public health, providing the evidence needed to make informed decisions about disease prevention and control. Epidemiologists are like data detectives, using various tools to understand disease patterns. One of their primary tools is counting cases. They track how many people get sick, where they live, and when they became ill. Mortality rates tell us how many people die from a specific disease. Incidence rates track the number of new cases, while prevalence rates show how many people currently have the disease. These numbers help epidemiologists understand the burden of a disease in a population. By comparing rates across different groups, they can identify at-risk populations and potential causes. These statistical measures are essential for understanding the impact of diseases and for evaluating the effectiveness of public health interventions. Epidemiology is not just about numbers, it's a multidisciplinary field that draws on knowledge from various scientific disciplines. Biostatistics plays a crucial role in analyzing epidemiological data. By applying statistical methods, epidemiologists can identify meaningful patterns and draw valid conclusions from their studies. Understanding the biological mechanisms of disease is essential, and epidemiology integrates knowledge from biology, pathology, and physiology. This helps identify risk factors and develop effective prevention strategies. Social and behavioral sciences, including sociology, anthropology, and psychology, provide insights into how social factors, cultural practices, and individual behaviors influence disease spread. While modern epidemiology emerged in the 19th century, its roots stretch back to ancient civilizations. The ancient Greeks were among the first to recognize the connection between environment and health. Hippocrates, often called the father of medicine, challenged the prevailing belief that diseases were caused by supernatural forces. He emphasized the importance of observing the natural world and considering factors like air, water, and location in the spread of disease. In the 17th century, John Graunt, a London haberdasher, pioneered the use of mortality data to understand disease patterns. His analysis of London's bills of mortality revealed striking differences in death rates between men and women and between urban and rural areas. Graunt's work laid the foundation for modern vital statistics and highlighted the importance of collecting and analyzing population health data. Section 5. Sailing towards health. The scurvy puzzle solved. For centuries, scurvy, a debilitating disease caused by vitamin C deficiency, plagued sailors on long voyages. James Lind, a Scottish naval surgeon, conducted a groundbreaking experiment in the 18th century that would change maritime history. Lind suspected that diet played a role in scurvy. He divided 12 sick sailors into 6 groups and gave each group a different dietary supplement. The group that received citrus fruits showed remarkable improvement. Lind's experiment, though conducted on a small scale, demonstrated the importance of controlled trials in evaluating the effectiveness of treatments. His findings led to the inclusion of citrus fruits in sailors' diets, significantly reducing scurvy cases. Lind's work marked an important step towards understanding nutritional deficiencies and their impact on health. Section 6. A Stitch in Time, Edward Jenner, and the End of Smallpox. Smallpox, a highly contagious and deadly disease, ravaged populations for centuries. Edward Jenner, an English physician, made a revolutionary discovery in the 18th century that would change the course of medicine: vaccination. Jenner observed that milkmaids who contracted cowpox, a milder disease related to smallpox, seemed to be immune to smallpox. He hypothesized that exposure to cowpox could protect against smallpox. To test his theory, Jenner inoculated a young boy with material from a cowpox lesion. Weeks later, he exposed the boy to smallpox. The boy remained healthy, proving Jenner's hypothesis. Jenner's discovery led to the development of the smallpox vaccine and the eventual eradication of this devastating disease. His work laid the foundation for modern immunology and the development of countless life-saving vaccines. Section 7. Death's Ledger, William Farr and the Language of Mortality. In the 19th century, William Farr, a British physician, revolutionized the way we understand and track mortality. As the compiler of England's vital statistics, Farr recognized the need for a standardized system for classifying causes of death. Farr developed a comprehensive system for classifying diseases, enabling more accurate comparisons of mortality rates across different populations and over time. His work made it possible to identify health trends and pinpoint areas with unusually high death rates from specific causes. Farr's system formed the basis for the International Classification of Diseases, ICD, a globally used system for classifying diseases and health problems. This standardized system is essential for monitoring global health trends and guiding public health interventions. Farr's work highlighted the importance of accurate data collection and analysis in understanding the burden of disease and identifying public health priorities. Section 8. Mapping the Invisible Enemy, John Snow and the Broad Street Pump. John Snow, an English physician, is considered the father of modern epidemiology for his groundbreaking work during the cholera outbreaks in London in the 19th century. At a time when miasma or bad air was believed to be the cause of cholera, Snow suspected contaminated water. During an outbreak in 1854, he meticulously mapped cholera cases in London's Soho district. Snow's map revealed a cluster of cases around a public water pump on Broad Street. He persuaded local authorities to remove the pump handle, and the number of new cases plummeted. Snow's investigation, known as the Broad Street Pump Study, provided compelling evidence that cholera was spread through contaminated water. His meticulous data collection, spatial analysis, and insightful deductions revolutionized our understanding of infectious diseases. Snow's work established the importance of careful observation, data mapping, and hypothesis testing in epidemiological investigations. His legacy continues to inspire epidemiologists today as they tackle new and emerging health threats. Section 9. Epidemiologists at work, from outbreaks to chronic diseases. Epidemiologists play a vital role in protecting public health, investigating a wide range of health issues, from infectious disease outbreaks to chronic conditions like heart disease and cancer. During outbreaks, epidemiologists work tirelessly to identify the source, track the spread, and implement control measures to contain the outbreak and prevent further cases. They conduct surveillance, collect data, and analyze patterns to understand the disease's transmission dynamics. Epidemiologists also study chronic diseases, identifying risk factors and developing strategies for prevention and control. They conduct large-scale studies to investigate the role of genetics, lifestyle, and environmental factors in disease development. Whether investigating a new virus or studying the long-term effects of air pollution, epidemiologists provide crucial information to inform public health policy and practice. Section 10. Challenges on the horizon, emerging diseases and global health. The field of epidemiology faces ongoing challenges, including the emergence of new and re-emerging infectious diseases, the rise of antibiotic resistance, and the growing burden of chronic diseases worldwide. Globalization, climate change, and urbanization create new avenues for disease transmission and pose unique challenges for epidemiologists. International collaboration and data sharing are crucial for detecting and responding to global health threats. Epidemiologists are also at the forefront of addressing health disparities and inequities. They work to understand and address the social, economic, and environmental factors that contribute to health disparities within and between populations. As we face a future characterized by complex health challenges, epidemiology will continue to play a vital role in protecting and improving global health. Section 11. A Legacy of Discovery, a Future of Prevention. From the ancient Greeks to the pioneers of modern epidemiology, the quest to understand and control diseases has driven centuries of discovery. Each generation of epidemiologists builds upon the work of those who came before, adding new knowledge and refining our understanding of health and disease. Epidemiology has given us the tools to eradicate smallpox, control polio, and understand the risks of smoking. It continues to provide critical insights into emerging infectious diseases, chronic conditions, and the impact of environmental factors on health. As we face new and evolving health threats, The field of epidemiology will continue to evolve, adapting its methods and expanding its reach to meet the challenges of the 21st century. The legacy of discovery and the commitment to prevention will continue to guide epidemiologists as they work to create a healthier future for all.